Okay, hi everyone. Welcome to today's system design session. Today we are going to discuss the design of a chat application or chat system. So as usual, I have the coder pad. I'll put the coder pad link into the chat. And the whiteboard. So I would like to call for a volunteer want to try to design the chat system. Anybody want to try this out? Anyone? Okay. So can you guys hear me?
Yes.
Okay.
Nice.
Yes.
Okay. Yeah, since we don't have anyone want to try this out, I would like myself to design this system. So let's make it clear that what's the requirement for our system. So let me share my screen. System. Okay. Okay. Can you guys here see my screen?
Yes.
Okay. Good. Okay. So this is a chat system, and the requirement. Let's make the requirement for this system would be like obviously peer-to-peer chat, and the next thing is the group chat. There are two important chats here. So these are two features, and the volume of this system. How many the active users? We don't have the active users. We can see how many users we have for the for other systems. Let me take a look. So we have the system like how but I just find that the WhatsApp system, they have 1.5 billion monthly active users. Obviously,
Wow.
it's a lot. So let's make now that crazy. So let's say that we can have 100 million users, active users. So those active users will sorry. Yeah, 100 million active users, they are going to talk with each other daily. So that's why they are active users. So yeah, this is how big the system is. And what other requests? Can you guys see anything here?
So in this requirements, are we not going to take anything about the notifications and all that?
Yeah, that's the important part of the chat. So that's right. Notification, but it can be part of the chat itself. Like if, for example, if this is a person to peer-to-peer chat, when we have when one user send a message, another user will receive it immediately from their phone. And the group chat is so the group chat. If anyone chat in their system, in their group, all the other users will be notified. So yeah, that's right. So let's make the assumption that other users will be notified.
About the current status, like online status or offline status.
Yeah, that's right. Status. Other, I would say that online user, maybe. Online user will be notified by others.
And what about like how we are going to store the chat? Are we going to store all the history in cloud, or are we going to store locally on the device?
That's a good question. So let me finish this offline and where the chat history. So so we can let's assume that history is on the cloud. It's history in server. So in this way, we can merge the peer-to-peer chat and group chat to be together. So peer-to-peer chat will be a special very special because there is one chat room, but there will be only 2 users. So this makes our design simplified. Okay.
So the chat will handle all the text, media, everything, right?
I would say that design is make it simple first.
Okay.
Chat text only.
Okay.
So upload images is not supported, at least now. Uploading should be. Yeah. Okay, so we have this is a group chat. Sometimes maybe only 2 users, and other users will be notified when one user who is online. Sorry, other online users will be notified when one user chats, and that can be online and offline. So that means that we have the phone. If the phone is connected to the server, let's assume that this user is active. Yeah, there could be some special settings, like if the user is connected to the network, but it may not on itself be show us online. So that's another thing. There's some details we don't want to discuss about that here. Okay, so yeah, I think pretty much we have everything here.
The one another thing which I think would be important is security. So generally, we would want to encrypt the chat messages before sending over the network.
I think that's a very good topic about security, but I don't want to talk in this system.
Yeah.
But yeah, maybe we can find another session talking about all kind of security related thing if you can think this is about the system design.
Yeah, I mean, we can just basically abstract out by saying that like we will encrypt the message before sending it over the network, and on the receiving end we will decrypt it. But
Okay.
I think that's
yeah,
important.
Encryption. Yeah. Let's put encryption and other things to not be in this scope, but yeah, because encryption definitely is very big topic.
Yeah.
Yeah, I think it's worth to have a separate session. And the other users saying that authentication is also very big topic, I would say.
Yeah. Yeah.
Yeah. So
I
these
think
are
it's worth
like,
talking.
yeah, these are like functional requirements now. Like, shall we discuss about the non-functional requirements like availability and consistency?
Yeah, sure. That's I'm not sure. I'm not sure if not the functional feature. That's maybe we can have some design. So here, so from the number that we have 100 million users, and daily thing that how many daily messages. Let's say that let's assume that daily people will send 5 messages a day. Is it allowed? Maybe, yeah, 5 per day per user. So totally there will be 5 million messages a day. Or let's make a quick estimation that every day there are here. There are 6,400 seconds. It's similar to 1 to the 5 second. This is per day. So we have 5 million messages per day, and this second. That means that we have and what that should be K
5K.
100K. That's I think 100K. That is means that we have every second we have 5K per second message, and yeah, I think this is very tough for a single machine. So definitely this is a very good reason we need to distribute our system, and it can be 3 times the current number, so it's 15K per second. Yeah, and also we want to make sure the system have some basic reliability. So that's another reason we need to distribute this traffic out into different machines. So yeah, so they say the traffic, and we probably need. So I was usually I was suggest that one machine can handle at most at most 1,000 per second of request. So we need at least 15 machines, 15 nodes at least. So there could be more for duplicate. Okay. Yeah, this is traffic. So now let's go to how you want to.
Yeah, one question. How did you decide that like 5K per second? So how did you decide like this greater than 15? Like how we decided like how much data or throughput of one node per second?
Yeah, this is some experience. I don't know where this is coming from, but I heard some articles say that usually one node can handle 1,000 per request, 1,000 requests per second. I think this is
1,000 requests per second.
yeah. This is just an estimation. Like we can assume that it can be a database, it can be a web server, and load balancer something that can be different because they are super lightweight.
Okay,
Yeah.
so this is purely on assumption basically.
Yeah, this is some assumption. All right. And what else we have? Yeah, this is scale of the system, and we can.
Storage capacity.
Yeah, that's right. You're right. Storage capacity. We have 5 million messages per day. That means that we have how many days? We have 365. That's 400 days. per year. This is crazy estimation, but makes the calculation much easier.
Sure.
So that means that how many zeros we have? 4 zeros, million messages.
Okay.
So that also means that this is giga messages. And each message can be how big?
Yeah, each message,
100,
if we take
100 maybe.
100 bytes.
Yeah.
Okay.
What do you think? What's your assumption?
Yeah, 1K should be okay, right?
1K, I don't.
1K. Yeah, maybe 1K.
Uh-huh.
And that is not very very
Yeah.
well. So 1K per message. That means that we have the storage of 200 terabytes per year.
Yeah.
That's right. Okay. So that means that the backend database will be pretty big. So yeah, definitely that's the storage will be a cluster. That's and fortunately that we don't have to worry. There's no complicated query accessing, so we can use some NoSQL database to deal with this because we need a big big chunk of data, and we don't have a very complicated query because most of the query should be by ID, user ID to find a message, or maybe some message ID.
Mm-hmm. So when we say we have a chat history in the server, so if we are having a history for a year, so this is what we need, right? But
Yeah.
if our history says we need the history of all our chats for last 5 years, usually that is what it comes to, right? Most of the time.
Yeah, we should have reserved the.
Is it really required for such a chat application? I'm just, thinking loud.
Yeah, I think that's reasonable because if one message is pretty big, 1K message. I still think that 1K message is pretty high, but yeah, I think that it's not very. It's still somehow reasonable. So because the database need to handle totally 1 petabyte of data.
Okay.
Yeah. So there could be I don't know what. So each node, each database may have. Oh yeah, that's right. Because we don't have to always need to access a history, very old history. So maybe we can have a hierarchy system, of the access. So maybe we can store everything recent in the some recent some dedicated node, maybe 10% into some fast system, and the remaining 90% of the history, we can compress it and archive them somewhere.
Okay. Yeah,
So
that
yeah,
makes sense. Yeah.
yeah. So because we have such a big data, and we need to really think about this in our system. Okay, we have the storage, we have the users, and we can start.
So why did you say NoSQL to store this data?
This is the proposal.
And why is that proposal?
Because we query, we should. Yeah, I think we need to talk about during the discussion because we are not very clear. My intuition is that this system is a system that query by ID only, either the user ID or it is chat ID. So we don't have to do the query like sort by date. Maybe if we have a chat, and then we probably will append the date. But Yeah, you can see that we have only several non index to query. So most likely we will use the NoSQL, but let's discuss it further. Sounds
Okay.
right?
Yeah.
Okay. So next thing, let's discuss the data first. Data, how it looks like. So we will have table.
So,
We have the user table.
so one question. So this system will be more consistent or more available in terms of cap theorem?
I think in this case, we don't need to be very high consistent.
Why? Because if I sent a message and it's lost, then that requires more consistency, right?
Yeah, that depends on the interviewer. What do you
So
guys think? I think,
consistent, one thing to mention is that by consistency in CAP, it does not mean that the system is inconsistent. It means it's eventually consistent. So your messages will not be lost, but they will
that's
be
slow.
eventually delivered.
Yes, yes, that's right. But yeah, I'm just trying to think like for this case, uh, to me, like so it looks like for this, like for the chat system, it should be available, and yeah, and consistency is also important. So like yeah, I felt like both are equally important.
Yeah,
But you're right,
yeah,
like
your
it
judgment
can be
being,
eventual consistent.
yeah, there's a consistent availability partition tolerant. It's either be the I remember the CP or AP system. It can be
Yeah,
satisfy all the criteria at the same
Yes.
time.
So I think availability is more important here, because if I send a message and if someone is not able to immediately see that message, so you see what it says in consistency, that every read receives the most recent write or an error, right? So
Yeah.
that means I can see the stale data. So seeing the stale data is probably okay here, but my application should always be available. If my chat system is not available, then the users will think that, like, will not have a great impression of my system.
Okay. So we are thinking this can be AP system, like
Yeah.
we request a read and that read can be old and the read is on the way.
Yeah.
yeah,
Okay.
yeah, makes sense.
Okay. Yeah,
And
I
I
think
don't
this
know
is the right thing.
what will be the design, but might be will not even hit DB when we are doing peer-to-peer chat.
But we need to store the history.
Yeah, history. So that's what, if it is eventual consistent also, no problem. But real time, we might not be even going to DB route.
Yeah, we can, in this system, we can optimize that. If it's a P2P thing, we can send the notification. We can send notification to the another person first. Well, maybe at the same time, we store the chat history in our database. What do you think?
Yeah,
Because,
so that's
yeah,
why I told, like, I don't know what will be the design, but right now I can visualize that if two people are chatting, it would be really direct communication, and keeping in the database would be a kind of a asynchronous operation.
yeah, that database is more like
Storage, like
yes,
a
like a
history,
storage, like a
and
streaming.
yeah, and or if somebody is not available, later that person can pick up the latest messages or go back to the history. So even if it is eventual consistent, I don't see an issue here.
Oh, okay. Yeah.
But we have to be careful with the ordering.
Yeah, ordering is really important, but I think every message would be having some timestamp, so we have to be careful with that.
What do you mean auditing?
Oh, ordering. He meant order, like order of message. Although it's eventual consistent, but it should store in the order we have received them.
That's right.
Yeah,
So
I think Abhishek, you meant that.
yeah, I mean, if I'm asking a question, how are you, and you're saying I'm fine, then how are you should come before I'm fine. If the
Yeah.
order is mismatched, then
Oh, that's right. I remember last time we talked about this.
Yeah.
Order, that is a very tricky thing.
Yeah,
So,
okay.
yeah, we can. I think I'm going to talk it very soon because I'm going to talk the database and I'm going to talk about the architecture very soon. So table, we have the table database table of user, and that could be very simple. This could have the user ID and then we have everything. We don't care.
Yeah.
Name, email, whatever they want. This is not important in our system. And another thing very important to our system is the history of chat history. So in this case, yeah, I think we may make an assumption that if we have a group chat, that can a new user join in this group? And if he joins the group, can he see the old chat? I think we want to make this is a requirement group of the group chat. So I want to make this assumption, make this easy, that there will be no user. We don't want the new user to join this this group chat when after this is created. So what do you guys think?
yeah, probably like fetching last like 15 or 20 messages from the history if a new user joins the group.
Okay, that will make this.
Or whenever a new user join, he can only get the current messages, right, from the timestamp. Yeah.
Yeah, that makes this table of the history can be hard because we keep the history of the messages for a certain group, and how can we know that who can have the access to which message?
So whoever is the member of that group, right? So basically each like chat session will have that unique ID. So if it's a group chat, it will have that unique ID of that group. And then in that group, who are the members? So for all those members, they can access the chat for that group ID, right?
Yeah, we can have a list of user ID. This can be changed later, so we can have this. Oh yeah, this can be a problem that if we want to, we have the group ID and the list of user ID, and if how can a certain user to see that which group he can access? Because there could be a query, and that can be.
I think it should be a many-to-many relationship.
Yeah,
one
you're
group
right.
have multiple users and one user could be. So there should be two tables actually. One is just a group table, group ID, group name. And then there should be a group relation table. It should have group ID, user ID.
Yeah.
And
both of these can be both of them can be the index here. Oh, wait, let me see. one user can have multiple group ID and one group ID can have multiple users. So
Mhm.
this item itself is unique, but we need at least 2 indexes.
Yeah, they would have their own index in their own table, user table, or or if you see this both combination is like a primary key. Group ID, user ID. It's a unique combination. So you basically need one index, I think.
No, he's talking about this table. Each table has its own index, right?
Yeah, so user ID, table user would have user ID, table
Yep.
group per group ID. But why we're spending too much time on indexes? I think uh, we
Hiren,
should.
I do have a concern here that, I mean, initially you mentioned that we'll consider the NoSQL and
Yeah,
the schema we are thinking in terms of relational.
No, but again,
I
this would
think
be
this is,
translated into NoSQL also.
yeah, if we, how we acquire the data is a very important factor. Decide when we are using whether we are using the NoSQL or SQL. So that's why we probably will decide, make the decision after the database.
But can we consider first peer-to-peer, or do we need to discuss in detail about group chat feature for the table design?
Um,
That could
I
simplify.
think I joined late, but it was mentioned that peer-to-peer is special group with only 2 users. So
yeah, I feel
technically this design table design should work.
for the P2P, yes. And yeah, I want to make the design simple.
Or
Because
we might want to have peer-to-peer as a separate.
peer-to-peer can be separate, and we can decide that want to we don't want to store the history, and that will be very simple. So because we can see who is online, and we can send a message, and then we forget about the message itself.
Okay, but okay.
Yeah, I think that's right. We can make this simplified, and we can talk about peer-to-peer without history, and then we can jump into the notification part. That's another part about I really want to discuss in this design. What do you guys think? Should we do you guys want to talk about the P2P only or continue on the group?
I think it's fine now. We are already here. Like,
Okay. Yeah. Okay. Let's continue.
Yeah.
And finish this part. So let's assume that we already have the group relation here. We have the group ID and user ID. And if we want to join the chat, let's forbid this one. Let's make it not allowed for now. And if we have time, we can talk more later. So then we have the group relation and here, and then we can have the chat history. So chat history could be, we have the group ID and timestamp and message. Message can be complete, can be image actually, but we don't care about this. So we have the chat history, we have the group relation, we have the group, and we have user. I think we have everything. And
don't we want to store something like who is the sender and receiver of the message?
oh yeah, that's right. The user ID, and there's no receiver because we already in the P2P is a special form of the group. So the other person by default will be the receiver. Okay, so database structure is done.
So
And
one thing I would rather store it as sender ID and receiver ID. Sender ID could be just a user ID, and receiver ID could be either a user ID when it is peer-to-peer, or it could be a group ID if it is a group chat.
But we can find out the receiver from the chat history and the group and the group relation. So if we have these two tables, we can find out who is the receiver. And I think when we are using the system, we can.
But how, like, because that user could be talking to multiple people in multiple groups, so how do you know that this message was intended as a send to which group or which user? How will you know that?
Because we have the message, we use the group ID, we know that which group we are talking to.
Yeah, so this group could be either a group ID or it could be a user ID, right?
Just a group ID.
So how are we storing then peer-to-peer?
So in the peer-to-peer, we have a group, and in this group we have two users. So there will be two items, the group relationship item.
Okay,
and,
you're saying, okay, so group, okay, got it, okay.
Yeah, so in this way, we don't have we don't have to consider the peer-to-peer.
Okay, yeah.
Even though they can be optimized, but let's talk about the group first. So yeah, we have these several tables here.
So Hiran, with this design, how will you fetch the group ID for a particular user group?
What's that? How can I use which one?
So let's say you are you and me make a group, right?
Mm-hmm.
So you want to send me a message. So how will you fetch that group ID?
We are in a group. Then
What
we
will
know
be
that.
your query on your table in that case?
Wait a second. Let me.
I think that will be to the group relationship table, right?
Yeah, if we have the group ID, then we can search. We can query the database who is in this group.
No, but
And,
you don't know the group.
we know the group.
You want the group ID to send a message, right? You want to send a message to me.
Yeah, you and me, and we have the group ID.
Yeah, so how will you get the group ID?
We already have the group ID here. If we open the room and, sorry, not the room. Yeah, let's say that if we chat to each other and we search the system, do we, let me see. So if we log into the system, I know the user ID, and then I can see from group relationship to see that which group I'm in. And for each group, I know that who is in this group. So some of the group is a real group that have multiple users. Some of them can have only one user. So that.
So you mean that, I mean, when you will fire a group to fetch the group relation, so you may have hundreds of records, and then you have to the linear scan for that another user?
Yeah, I will search, but this is mostly the one-time operation that we can have a phone and we log into the system, and the system will give us all the group and all their groups and all their users together. Then we can see that who I'm currently talking with. Like we are I open the phone and I know that I'm in group ID equals to 1, and in this group we have two users, you and me, so that I can check if I use my phone to chat to you, I can find that group, and we can continue the discussion. or we never talked before, so we can apply to the server to open new group and chat with each other.
So you're saying that the application will send the group ID, like when user is sending a message, then the client itself will know the group ID.
Yeah.
Mm.
Yeah.
Still,
So,
I mean,
what's
you
that?
guys okay with this design? But still, I mean, I feel that the server will have lots of load in that case. Every time user send a message, open a window to send a message to a particular user. So it will make a request to the server to get the group ID. And
No.
to get that group ID, it will not be, because that user may belongs to hundreds of group, right?
Mm-hmm. But this is the one thing. We log into the system, we open my phone, and the phone talk to the server only once at the very beginning. So only at the time. And also because everything is database reading, that have a lot of way to optimize. So we can have multiple copy of the since it's not a write, it's read, and we can have multiple replications, and the server can cache them anywhere. So I don't think that can be an issue, even though initially we have multiple queries, but later we don't have to do this.
Looks like I'm missing something here. Why we don't need to make this query in future? That's, if I understand correctly, you said that only we need to fire this query only once.
Mm-hmm. Yeah, we log into the system using my phone, using our phone, and we log in as user as ourselves, and we can at that time we will query the server to get all our groups and who are in these groups, everything, including the chat history maybe, or maybe most recent history.
Yeah, I mean, I don't see a problem like initiating that handshake initially, because anyways, when you will start a chat, you will type something like you have a lot of time. So it's okay if you maintain a once connection between client and server to uh, negotiate on what those IDs are.
Yeah, and there's also
So we want to keep these IDs, group IDs, on the user phone or whatever
in
device we
user's
want.
phone, yeah, in a device.
Yeah.
Okay.
Because we also need to store the history. So that's an important thing that we need to have the group ID to store the history. So
Okay.
yeah.
So basically, it's like when you are sending a letter, right? First, you should know your friend's address. So initially, you are getting that address. That is the ID. And now, whenever you want to send that message, you are referring to that ID. So you have to know that ID. If you don't know that ID, let's say if you have reformatted your phone or something, then you have to get that ID again once. And once you have got that ID, then you will use that ID to send those messages.
Yeah. So initialize your phone is have the burden to the server, but in the real life, it's have a much higher burden to yourself. So not a lot of people will do that. Okay. Yeah. Do you think do you have other questions?
No.
Okay. Let's go to this system. And actually, the system will not be very complicated. Let me get my pad here. Okay, you write something. Oh. So make it 100% of the Zoom. Okay. The anonymous. Okay, yeah. So this system, my thinking is that because we have multiple servers to handle the communication, so so there will be a server to access the there will be a server to access the database and other services like notifications. So we need to have a load balancer in the front because it's a really big server. And behind the load balancer, we balance out all the requests into different nodes. There could be a lot of nodes there. As we can have the we have the estimation that we may at least need 15 nodes. Oh, I think someone have the chat say something. In relation table, we can fetch index or maintain the cache. Okay, yeah, that's right. Relationship table, we can find a way to cache the data. So then we can have each node will handle the operations like I think we need to talk about API first, what kind of thing. So we have the sync. We have some API called sync sync user group. So basically, find out all the groups and user IDs, groups and its user ID for user. This is sync user group. So this is a very initial work. And it can also be some operation like you think that your phone is in bad condition, so you can still use this API to sync the data. And the next thing can be another operation can be send message. I think we can have the group ID and the message. And another operation can be the what other things? Another thing can be online. So it's tell the server that I'm online. So there are basically 3 operations. So here we have a very same design. Oh, another thing. It's online and send message. Sync message. We need message ID for order. We can rely on the timestamp, but how about the message ID, how we generate that? That can be a problem. But yeah, I think we can talk about this right after. Once I finish the when we finish the APIs sync ID group. So it put all the data or maybe time optional. Heartbeat. Why we need a heartbeat? Or maybe the online itself can be the heartbeat. So say that I'm online. What do you guys think? So I can periodically tell the server that I'm online. For last scene. Yeah, maybe, but the last scene not very important here. But anyway, I have a full message for APIs here. I talk the system. And the structure of this system can be very typical. We have load balancer, we have several nodes handle all these different operations. And at the end, we have the database cluster. So there could be a lot of data. And because this data is very big, I tend to choose NoSQL because they can handle a large amount of data. So, and for these tables, user table is called by user ID and group ID. So, and the chat history can be handled by the group ID. Group ID can be the primary key, so they can. Sorry, the primary key. That's what we call that in the DynamoDB term.
Compound key.
Hmm?
Compound key.
Oh, yeah, that's a compound key together. So there should be another. It's partition key. That's right. So this can be at least a partition key. So we can partition the system into different nodes. And this is a range key. Is it called range key? Can't remember. Sort key. That's right, sort key. Just like Shreya's mentioned that we need something to order the message. And the message, this thing can be, same group will be stored in the same node. So this will be, yeah, that. The only concern here is a group relation database because we have two columns and we need to query both of them in different scenarios. One thing we can do is that we keep one table, but we using the global global index. I'm not sure if any of you knows about the global index in DynamoDB, but honestly I'm not really familiar with that. I only know that we can index both of the ID columns, so that internally it will be kept as two separate tables. Anyone? I need some help here.
I think that's called secondary index, right? And there are like two ways to partition secondary index as well, either local index or global index. If it's a local index, then it will be on the same machine on which the primary index is there. If it's a global index, then again on index we can do hashing, and based on that hash, it will be stored on those machines.
Okay. If you have the local index, it will be stored in the. What's the pro and cons of in this scenario that we use a local index or global index?
Okay, so for the local one, the benefit will be like if we had when doing a write update, then the update will be on the same machine, for both indexes. But if it's a global, then we might have to update, we might have to write on more machines.
So if the local index will save money, we're trying to say, because this will consider as one write.
Right. And for global, while yeah, global advantage will be like when we are reading, we have to just read uh, 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 like a one machine where that global index is, where that index is basically.
Okay. So the local index will save more. Local secondary index will save money.
Uh,
And the global, what's the benefit of the global index here? I wonder.
so basically, like global index, like for example, like for this example, like one machine can tell like for this user ID belongs to which all groups. So that data is stored on one machine itself. But if it's local, then the secondary index will be that this user ID belongs to these groups. So for then local, it will only know about uh, two or three groups, but it has to since it's a local, right? So we have to read more machines to gather like collectively like that this user belong to what all groups. So for local, he has to for read query, it has to read many machines. But with
Okay.
global, it can go in just one machine and get all the groups in which this user belong.
So reading more machine means it's slower.
Yes, more, there will be more latency, right? Because we have to read from more.
Okay.
Yeah, we have to wait for the response from all the machines to gather the result and then return.
Okay. So if we're using a local index, reading is slower and it's expensive.
Reading will be slow and
Yeah.
write faster.
Okay. Write faster. Oh yeah, that's good to know that. I didn't know this. Local second index is read slow, write fast, and global index is read fast and write slow. Is it correct?
Yes, yes.
Okay. Yeah. In this way, I think the answer will be pretty clear that most of the time we just read. So global secondary index could be our choice. Yeah. And we can, in this way, we solve all the tables and we can choose NoSQL database.
But I think Abhishek asked earlier also, but why no SQL? Why not SQL here?
Because we have 1 petabyte of data
But
and
SQL,
we want to distribute them into different nodes.
but SQL databases like these days distributed, like SQL is also distributed and it can store large amount of data.
So they can party. Do we need to write the code to party to what they call sharding the data?
No, I think SQL also they provide like out of box feature. Like I don't know in detail, but I know like they also provide like SQL also we can do sharding. Like they there is a partitioning there as well.
Yeah, because my understanding that most the traditional SQL database, we can write the code to shard the data, and because traditional database require have the ability to query the data with other columns rather than the primary key. So the data need to be stay together. So that so there's no way for them to share the data. And I do know that replication can be guaranteed by the traditional SQL database because they can have the data they can replicate data into different nodes, but on this node, the data is a whole. So everything can be one node and two nodes, but we cannot have half of data in one node, half data another node.
Oh,
Yeah, that's my understanding. I'm not sure anyone knows about this more.
that's what I know. Like SQL also provides replication. Like that is like their default feature these days.
Yeah,
And
I
I know
think.
like Facebook uses like Facebook for their pretty some like huge services. They also use SQL. Like they have optimized the default MySQL or
Yeah, I think the user, this
like
can be
Postgre.
in the, someone
Now
talking?
what I'm saying, like for large distributed systems, Facebook also uses MySQL. It's not like they use NoSQL for all the services. Since Facebook has a very large scale, so even if they also use MySQL. So what
Yeah, I
I'm
think this is more like history reason.
okay. So
Yeah.
I think when you decide your partition key, so I don't see there is any issue with the SQL as well.
Yeah, that's right.
The
So
only
partition key,
benefit is that the NoSQL, some NoSQLs like DynamoDB or Cassandra, these database provide you this partition out of the box.
yeah,
You don't
I'm
need to do anything special. Though when you design your schema at that time, you have to decide what will be how will you partition your data. And after designing that your schema and putting that, there's no way to change it.
That's no easy way to change. That's right.
Yeah, I mean, in not easy way. I mean, the
Yeah.
same is applicable for SQL.
SQL, yes, SQL is definitely easier to change the schema because my understanding of the SQL, just like I say that it can query, and that brings a lot of problem with the design. So we cannot cut their data into different nodes. But in general, if the table can fit into the NoSQL database, it can definitely fit into the SQL database.
what I thought this would like NoSQL would fit because we have a we might have queries like fetch latest 10 messages for that group ID or like let's say 50 messages for that group ID. So we have a range query. So if since we are storing the like our third chat history table like based on timestamp, so like majority of our queries will be such queries like give me last 50 messages of that group. So range queries will be more for this data model. So if we use SQL that might like NoSQL supports better range queries than SQL. So
I think they are the same.
yes, that's what I was thinking.
Yeah, I think that in the query, SQL database definitely provides much more flexible feature compared to NoSQL database. So NoSQL database don't provide much feature, and that makes it more flexible to store data. So there's pros and cons in this thing. So yeah, I think in our discussion, I think at least the chat history need to be somewhere in the NoSQL database, and other things. Yeah, I think other table can be, especially group relation. We can put them as those three into a database because that won't be a lot of data. And this one can be a big problem. That should be in the database, in NoSQL database. What do you guys think? We have some we can divide this thing into different databases. Do you agree?
To me, sounds good.
Yeah, I think the group relation, we have how many users? We have 100 million user. And so let's say that each of them have 5 groups. So we have 5, how many groups? 100 million, and each of them have 5 groups on average, 10. So we have 1 giga thing. And yeah, that's pretty a lot. Not very. Yeah, you're talking about this. if each data can have 100 bytes to store the data, it's not trivial, I would say.
What is the issue?
Yeah, the issue is that if we store the group, we have, let's say that we have 100 million of users, and each user have 10 groups. In that is need to store each one of them have the 10 different. Oh yeah, there's another thing that they are talking to each other. Oh yeah, this is the same thing. That each user have the 110 unique groups. Let's say that. Let's say this way. That if we have one group and each group can contains 5 different users, so they are sharing the same group. So that means that we can have 2 or 2,
So
3
that 100 million, we are saying that the daily active user or total user?
active users. So we have more total users. Yeah, that's right. Because I checked WhatsApp have the 1 billion active users. So how many active users we have?
No, that's
Monthly active user 1.5 billion. So we want to down. We don't have much active users. So 100 million users. So that means that the total user can be higher than this number.
yeah. Then the total number of group will be based on that, right?
Yeah, maybe 5 million. Let's say with 20% of active user, 500 million users, and each of them have the 2 unique groups. So that we have 2 users. So let's say that we are talking, and I have it's me and you, and there's only one group. So each person have in this case, I have 0.5 unique group. So if we put them together, then each user may have 2 or 3 unique groups, and that's still 1 gig of items. And let's say that each item have 100 bytes. So that means that we still have we have 100 gigabytes of the storage. So yeah, I wonder that if one single SQL database can do it quickly, that could be a thing. That could be a problem. But it's a group relation that is read only and not a lot of write. So yeah, in this way we can still barely put them into the SQL database, traditional SQL database. So this is my solution. Any question? Any challenge?
For the group relational table, so it's primary key is group ID and user ID. Okay.
Yeah,
If,
both of them can be the index.
okay, but yeah, like if we use like a NoSQL for this as well, then like I know for HBase, like since HBase is column oriented, so it will be one row. So it will be like group ID and like then list of user IDs which belongs to this group ID. So that is also one more way if we store this table in NoSQL as well. And let's say if more users join that group, since it's a column oriented, like it can have more columns as more users join that group.
I don't really follow. Can you do you mind writing your thinking into this coder pad and or using the whiteboard?
Okay, so basically what I'm saying, like if we
Let me share and you can share.
Okay, sure.
Yeah, I think I would like to know more about this.
Okay. So what I was saying, like if we store this group relational table in HBase, then our group ID will be the primary key, and all the users which belong to this group will be the columns of this table. So basically, let's say for this group ID is for example, this group ID is 100, and this group has 5 users. So 1, 2, 3, 4, 5. These will be the columns of this row in HBase. And let's say if more users join this group, then we can simply append 6 and 7 to this row, which will, and by that we can identify that for this group what all users which belong to this group.
This is called the column-based.
Yes, this is column based.
Okay,
Interesting.
I have a different understanding of column-oriented storage. So basically, so there is two type of storage, right? Two type of database: row storage, column storage. So whenever your queries are such that you want to query a row, then it is more optimized to store the data in the row storage manner, like any kind of transactional processing. When you want to get that particular row, right? Whenever you are doing analytics kind of data, let's say you want to find the average of that column, or you want to find mean and all those values. In that case, you want to fetch the entire column records, right? Mostly your queries are for that entire column. In that case, row oriented storage is not efficient. So that's why you store data in those columns, and that's why any databases which are meant for analytics kind of processing of data, they are column oriented. But I don't know about HBase at all. This is like my understanding of row based and column based storage.
When you say analytics and column, you mean like can you give specific example?
So yeah, so in your, like, if you are working for any organization where, let's say, I have a table of sales, right? That this product and this sales, let's say I have a table like this. So when my queries are like this, that what is the sale of this particular product, right? What is the total sale of this particular product? Then I'm trying to fetch that particular row. So that is kind of a transactional processing. The other, which is analytics processing, is where I'm not worried about any particular row or something. I'm just doing analytics, that what was my average sales for my company in that particular month. So there I'm not trying to fetch that particular row. I'm trying to get that entire column of sales, and I'm going to take an average of it.
But how it is stored when you say column?
So that's why in the storage on the hard disk, in column-oriented databases, they are stored in the, like, a data of column is stored together. So that's why if you want to fetch that entire column, because that data is stored together, that's why you have you will take less those hard disk reads to read that much amount of data.
So
Whereas if it is, yeah.
you're saying in one row it will have all the sales which happened for that product?
Not row, in that sector. So in that hard disk sector, when you are storing the data, it will be stored in such a way that the data of that column is together. So in hard disk, right, you read blocks of data. So let's say if your data is separated in different blocks, then you will have to perform multiple sector reads to get that data. So that's why we try to optimize by storing the similar kind of data which we will need to read most often together. So in the row oriented databases, you store rows together in that sector, so that whenever you do whenever you do a read, you get that entire sector, and in that you have the rows data. When you are trying to do column kind of queries, then the data will be stored in the sector in the column form. so that you don't have to move across sector. Within that one sector read, 1 or 2 sector reads, you can get the data, what you're looking for.
Okay, okay. I think that might be a little lower level, but this is how it is done in HBase. This is like I have worked at Yahoo Mail, and like this is basically the design which we have used. So basically, instead of give me.
You are muted.
She said, give me a minute. So probably
Okay.
she.
Sorry for the interruption. So, yeah,
Let me see the
yeah, can you hear me?
space. Yeah, I can hear
Yeah.
you.
So yeah, what I was saying, like, yeah, no, so usually this is how the data is stored, like for this user ID, what are the messages? So messages will be just the message ID, and yeah, the message ID will be a different table. So the query will be like, give me the top, because when you open the Yahoo Mail, you will see the top 50 messages or 100 messages, right? So we will make a query in this table, say that for give me the all the latest 50 messages for this user. So this message IDs will be stored like this is like all the message IDs will be stored in the column uh, in the column.
Oriented. So I think, yeah, I think it makes sense, because why it makes sense is because here uh, we are getting multiple messages, right? And all of them belong to same column. So basically you are trying to read that particular column, which is messages. And so that's why they have stored it in column kind of storage,
Yes,
column oriented storage. Yeah.
yes, but we are trying to fetch a row which has multiple columns. So basically, the optimization is, let's say if I am a user who is not sending much messages, so I will have only 5 columns. But let's say if there is another user who is sending like more messages. So basically, what I'm trying to say is there is a variable size of data for each user. There is a variable set of messages. So we will have a like, yeah, we will like take advantage of the variable size of the nature here. So I see the same thing here, like not like here user IDs are not that high, but yeah, like there are like variable nature here, like maybe a group has only one user and a group has many users. So
Yeah, this is one of the use case to go with the NoSQL, where your schema is not defined, and still you are evaluating your schema. So then NoSQL help you, because in a particular table, each row may have a different number of column.
yes.
But
So
why do you need to create column for each message? Like, isn't it a very bad design? Like every time a message comes, you are creating a new column.
No, this is not. So
This is
whatever
the
she was
group
explaining,
relation.
that was not for
This is a group relation.
Yeah, even for group, why are we creating new columns? Why can't we store that in one column?
Yeah, if we want to make this immutable, we can
let's
put
say
everything into one.
initially you start with the
Yeah, your connection is not very stable.
Abhishek, why do you think like it's a bad design? Like if we
Because every time you have to recreate the schema of a table, it's expensive, right?
no, but in
So
HBase, that's what in HBase it's a column oriented, right? So that's a flexibility. You can add as many columns as you want on the fly.
Yeah, it seems that HBase may already consider in this scenario and make it faster.
okay.
But I need to,
Okay,
yeah, I think
yeah.
we all need to dig into the HBase a little bit. I just read some terms of the column and column family, column this, column that. I don't really know.
Yeah.
I never use those advanced feature. But yeah, it's very good to know. It's very good to know this thing.
I think DynamoDB, Cassandra, and HBase both are the same, similar type of architecture.
Yeah, I know that at least DynamoDB allows us to query the some key and then give us a bunch of data for this column. I don't know internally how this is implemented. Maybe just like what was it?
So I was reading that DynamoDB paper. That DynamoDB is specially designed for, I mean, if you want to make a query only on the primary key.
That's right. That's how it's designed, and give us a bunch of data. And the key thing of the group relation. Let me share my screen. The key thing of why we put this into different things is that we also need to query by user ID, which group is in. Let's say that I'm open my phone, log into my phone, initialize my phone, and I want to know that which group I'm in. We have multiple groups. Some of them could be P2P chat, and some of them can be the group chat, multiple persons. So we need to query by user ID to find all the group IDs. Okay, yeah, this is that thing. Where are we now? I'm kind of lost here. Oh yeah, I think we previously were talking about whether we need to use the traditional SQL database or use the NoSQL database. And we don't have the conclusion here. Because I find that if we store all the groups into a traditional database, it can be 1 gig of data, and querying that can be slow. So one thing that we can do is that we can, because this 1 gigabyte of maybe 100 gigabytes of data can fit into a single traditional SQL database node, and we can have the replicas around. So that will make the querying faster. Not the query itself, but balance the traffic. So that means that we can still have the user, have the group, and have the group relation into the traditional database to make our system, our program easier to write. And for the history, we need to use the NoSQL database like HBase, like the DynamoDB, Cassandra, because the volume is very high.
But isn't it difficult if I'm writing this application and now I have to manage 2 type of DBs? But like we can use NoSQL for others as well. Then like all my data would be in 1 type of DB and my application would be easier to write.
Yeah. So the thing is here, the user can be very flexible, and the group can also be that flexible. And group relation we only have 2 columns. So you see that we have data here. We don't know what we are going to add here. We may have some permission things. We may have some
group name or something.
Yeah, a lot of crazy things, and we may query the things. So yeah, that's my point. So but that's my design, and today we don't have much time. So let's wrap up, and next session we will talk more about the notification and other things. Okay.
And replication as well.
Replication can be the topic of the database itself.
What about archiving? You said, we will be archiving some part of it.
Yeah, archiving can also be a topic, and we can let's leave the topic we want to discuss here.
And we would also discuss the flow of how the message goes. Will that also be a part of this discussion?
Yeah, that's a part of notification.
Okay.
Notification and what else? I can't remember.
Archiving, you said.
Yeah, archive. Archive old history. And what else? The notification and the flow. This is one thing we need to go through all this. Yeah, this is something I don't want to forget. So the database, the chart is as usual that we have the load balancer, we have the cluster of the database, and some of them can be the SQL, some of them can be the NoSQL. So this is there's nothing very very unique in this design. And besides, we need to have a notification service. So this is basically a service that the node write a message and have the notification service that we have. We need to notify this user, this user, this user, and if some of them online, please tell them. But we need to leave this into the next section.
And how about caching? Do we need caching here?
Caching, we can, but let's do the optimization once everything is ready.
Yeah, like I'm just adding to the points which we can discuss next time.
Yeah, we can find a way. Yeah, that's it. I think that's it for today.
Yep, no problem.
And next time we will have a lot of things to discuss.
Sure, yeah.
Yep. Thank you.
Thank
Thank
you.
you. Thank you, guys.
Thank you.